In this video, we will discuss how we can find lowest common ancestor of two nodes in a binary tree. So lowest common ancestor or LCA between two nodes n1 and n2 is the lowest node that has both n1 and n2 as descendants. Here the condition is that a node can be descendant of itself. And the assumption of LCA is that both the nodes n1 and n2 are in the tree. So let's see an example. So this is our node n1 and this is n2. So let's take the first example. N1 is D and n2 is P. So we have to find LCA for D and P. So P is descendant of D and D is descendant of itself. So the LCA of D and P is D. Now let's see the second example. So n1 is H and the second node is P. So P is descendant of L and D and H is descendant of D. So the lowest common ancestor is D. So for H and P, LCA is node D. Now let's check this third example. So now node 1 is Z and node 2 is B. So B is descendant of C and Z and Z is descendant of itself. So the LCA is Z. Now check the last example. So node 1 is L and node 2 is B. So B is descendant of C, Z and A and L is descendant of D and A. So the common node is A. So LCA for node L and B is node A. Now once we've understood the definition of lowest common ancestor, let's see the algorithms to find it. So we'll discuss two algorithms. Let's see the first one. So the algorithm says store path of root to n1 in an array. A is the root node. So array 1 in which we store path of root to n1. So the path is A and D. Now the second step is store path of root to n2 in another array. So in array 2 we store the path from A to P. So it is A, D, L and P. Then the LCA is the common element in the arrays just before the mismatch. So if we compare these arrays, the mismatch is at third node. So the LCA is node D. So we have to pick the node just before the mismatch. So LCA for D and P is node D. Let's see some other examples. Let's pick H and P. So N1 is H. So array 1 is A, D and H and array 2 is A, D, L and P. So the mismatch is on the third node. So we have to pick the node before the mismatch. So here also LCA is node D. Now let's check the fourth example. So node 1 is L and node 2 is B. The path from root to node N1 is A, D and L and path from root to node N2 is A, Z, C and B. So here the mismatch is on the second node. So the LCA is the first node which is A. So in this manner we can find LCA using this algorithm. But this algorithm is not very efficient because it traverses the tree twice and also the space complexity is order of n for keeping these arrays. So let's look at a more efficient algorithm where the space complexity is order of 1 and we traverse the tree only once. So this is the efficient algorithm. Here the space complexity is order of 1 and the time complexity is order of n. So this algorithm tries to find both node n1 and n2 in the tree. So let's say this is our tree, this is the root and this is our subtree 2. So this algorithm states that if node n1 is in the subtree st1 and node n2 is in the subtree 2, that means the root node is the LCA. The second case is if both nodes lie in the one subtree. So that means LCA would also be present in this subtree. And the third case is if the node n1 or n2 is the root of the subtree itself. That means n1 or n2 is the LCA. So this algorithm is based on these three conditions. Let's have a look at the pseudocode. So the first call to this function will be for the root of the tree. So here the node is A. We check if it is null. Then we check if value of node is equal to n1 or n2. So n1 is L, n2 is B. So these do not match. So we come here. So now we call LCA function again for the left of A. So left of A is D. So for A, L node is LCA of D. So now the node is D. We check if D is equal to N1 or N2. And then we again call LCA for the left of D. So L node for D is LCA of H. So now the node becomes H, and L node at H is LCA of null. When node is null, we return null. So L node becomes null, and R node is also null for H. Now we have both L node and R node at H. We check if they are not equal to null, then we check if left node is not equal to null, and then we return the right node. So this function returns null. So L node at D becomes null. Now we have to calculate the R node. So R node is LCA of L. So now we come at L. So when the node is L, we check if node value is equal to N1 or N2. So node value is equal to N1, so we return the node. So from here we return node L. So right node of D becomes L, and once we have both left node and R node at D, we check these if conditions. So one of these is null, then we check here if left node is not equal to null. So left node is null, then we come in the else part and we return the right node. So this function returns node L. So for A, the left node becomes L, and now we have to calculate the R node for A. So the R node is LCA of Z. We come at Z, L node is LCA of C. Now we come at C, L node is LCA of B. So now we come at B. So the node is B. We check if value of node is equal to N1 or N2. So now B is equal to N2, so we return the node. So this function returns B. So left node at C becomes B, and R node is LCA of G. We come to G, L node at G is null, and R node is also null because left and right is null. So this function returns null. So R node at C is null. So now we have both L node and R node at C. So this function returns left node, which is B. So this returns B. So left node at Z is B, and right node is null because right of Z is null. So at Z also we return B. So right node at A becomes B. So now for node A, the left node is L and the right node is B. So we come in the if condition and we check if left node and right node is not equal to null. So both are not equal to null, so we return the node. So the node is A. So LCA for node L and P is node A. So let's see one more example. So now we discussed for L and B case. For L and B, the LCA is A. Let's check the first case. So now node N1 is D and node N2 is P. We start the traversal from A. So left node at A is LCA of D. So we come at node D. So when the node is D, we come in this if condition, and now the value of node is equal to N1. So we return the node D. So this function returns D, and L node at A becomes D. So now we have to calculate the R node at A. R node at A will be LCA of Z. We come to Z, and here the L node is LCA of C. Now we come to C, L node is LCA for B. At B, L node is null and R node is also null because left and right is null, and this function returns null. So L node at C is null, and then we calculate R node at C, which is LCA for G. So function at G will also return null because left node and R node are null. So R node at C also becomes null. So LCA for C also returns null. So L node value at Z becomes null, and R node is also null because right of Z is null. So LCA for Z returns null to A. So now at node A, the left node is D and the right node is null. We check this if condition. So if left node is not equal to null and right node is not equal to null. So here right node is null, so we come in the else part and we check if left node is not equal to null. So left node is D, so we return the value of left node. So LCA for D and P becomes D. So in this manner, by recursively calling for the left and right subtrees, we can find LCA for any two nodes in the tree. Now once you've understood this efficient method, let's have a look at the implementation. So all the source code that I'll be showing is available in my GitHub repository. Link of that is available here and as well as in the description. Now let's have a look at the code. So in the main function, I've created this tree. The root node is A, the left node is D. In this manner, I've initialized all the nodes of the tree. Then I have this function LCA in which I pass the root node and the node N1 and N2. So I'm calling this function 4 times. First I'm passing D and P, then H and P, then Z and P and L and P. So this LCA function will return with the pointer to the ancestor node and then in the main function I print it. Now let's have a look at the LCA function. In the LCA function, I check if the node is null, then I return null. Otherwise, I check if node value is equal to n1 or n2, so I return that node. Then I recursively call the LCA function for the left and right subtrees. If I get a value for left and right, that means the root node is the LCA node. Otherwise, if left is not null, then I return the left node. Otherwise, I return the right node. Now let's have a look at the output of this program. So LCA for D and P is D, for H and P is D, Z and P is Z, and L and B is A. So that was all for this video. If you have any doubts or suggestions, please leave in the comment section below. If you like my content, please do like, share, and subscribe to my channel. It really motivates me to make more such content. And until next time, this is Sandeep Thapar signing off.